first thing I'd like to touch on is network communication. A network communication can be modeled by the 7 layers of the OSI model. Here's a picture of the OSI. Ethernet and anything with transmitting information is taken care of on the first 2 layers called the physical layer and the data link layer. There are 3 types of devices that a user can choose from when a user wants to connect 2 or more devices to a local area network or a wide area network. The first device is called a hub. From this picture, we can see that a hub is connecting computers A, B, C, and D. The second device is called a switch. Again, from this picture, we can see that a switch is connecting 4 other computers, also labeled A, B, C, and D. The difference between a hub and a switch is that a hub will make copies of data packets and send it to all of its ports. This method wastes a lot of bandwidth because not all the computers need the data packet information, but the hub will still send it. Unlike the hub, the switch only sends data packets to the computer that is requesting it. This method is done through MAC addresses. Each port has a specific MAC address, therefore if computer A requests some information, the switch will send information to the MAC address that is connected to the port where computer A is connected. The third device is called a router. A router is used to connect devices to the wide area network. Unlike the switch or hub, a router connects devices to other networks, not just the local area network. In the picture, we can see that the router is connected to a modem and a switch that is connected to computer D and E. The router is also connected to the computers A, B, and C. The picture shows how the router is bridging together the computers, the switch, to a modem.
Greetings, my name is Zipporah Robertson and I did my segment on Gigabit Ethernet. As you can see here, this is basically just a diagram of deploying Gigabit Ethernet, basically how it is transmitted throughout different devices and services. The most recent development in the Ethernet standard is Gigabit Ethernet. Also, it is a protocol that has a transmission speed of 1 gigabits per second, used in both fiber optic cabling as well as copper cabling. Primarily, Gigabit Ethernet was used for backbones on a network. Also, it was used for workstation and server connections, as you can witness above.
Hey guys, this is Chase Gibson, and in tonight's episode, we will be talking about Ethernet bridges.
In the following diagram, it displays the connections made between a broadband modem, wireless router, and other hardware devices. This type of setup allows for 2 options of connecting to the wireless router. One option is to use Ethernet cables to interconnect the hardware devices over to the wireless router, and the other option is to connect the hardware devices over to the wireless router via Wi-Fi. You can also combine the 2 options for a more efficient internet speed. By combining the 2 options, it would allow easy access to the internet throughout your house while also keeping the desired speed that an Ethernet cable can provide. In this new diagram, it replaces the wireless router with an Ethernet router. All of the hardware connections are made via Ethernet cables in this method. This method transfers data faster than using just Wi-Fi. When using Wi-Fi, there is a bandwidth assigned to this network, and the more hardware devices on the bandwidth, the less internet speed you will receive. In Ethernet, you can disregard the assigned bandwidth because you are directly connected to the router, giving up convenience for speed. In this diagram, it combines the last 2 methods by attaching a wireless access point over to an Ethernet router. Like before, the connections are hardwired via Ethernet cables. What makes this design special is that the wireless access point groups together hardware devices and interconnects them via a wireless access point. This method is more efficient than just using a wireless router because you get the speed that Ethernet can provide as well as having the convenience that Wi-Fi provides as well. The final method of connecting a bridge is through a power line adapter.
A power line adapter takes the data coming from a router and then allows the Ethernet signal to be sent through the power grid of a building.
Basically, a power line adapter changes the Ethernet data into a signal that can travel through the existing wires in the wall.
To get a signal anywhere in the building, all you have to do is plug in another power line adapter and connect that adapter over to your computer or hardware device via Ethernet cables.
Some newer models of power line adapters come with a feature that allows for a Wi-Fi or Ethernet cable option built inside of the adapter.
Oh, hello there. My name is Jocelyn Banga and I will be talking about 3 things in this video. The first one is how a collision works within a telecommunication system, the different types of errors associated with Ethernet, and the importance of jamming. This picture shows an example of a collision occurring as late as possible. A and B are set with 5 units, with 4 units apart and contain a bandwidth of 1 byte per unit. A will begin sending hello world starting at t equals 0, and B will start sending after A's message arrives at t equals 5. Although B has listened before transmitting, an A signal has not reached B. A will not know about this collision until t equals 10, which is 10 units. Now I would like to talk about 5 different error conditions. Their names are runt, long, giant, jabber, and dribble. A runt is a frame that is shorter than 64 bytes, which is actually the smallest allowable frame, and the error associated with this is that it can have a corrupted frame check sequence. FCS means that there is an extra error detecting code added frame in the communications protocol. A long error is between 1518 and 6000 bytes long. It is usually due to faulty hardware or software from the sending station. A giant error is similar to a long error, but it contains a frame that is more than 6,000 bytes long. Another form of error is called dribble. This is a frame that is greater than 1518 bytes, but still can be processed. Usually the problem is when the IPG is too small or non-existent when 2 frames join together. Lastly, the last form of error is jabber, and that refers to when a device is having problems electrically. Now I would like to talk about jamming. Jamming is the collision reinforcement signal sent by the repeater to all other ports. When a collision is detected, the NIC sends out a jam signal so it can let all other stations know that a collision took place. After a collision is detected, a repeater, which is in a particular port, will send a jam on all other ports, which will cause collisions and make all the stations wait before transmitting a signal. The station itself must first see the jam signal before it finishes transmitting the frame. If it does not, it will just assume that another station is the cause of the collision.
Thanks for watching this quarter's episode. Stay tuned in for the next episode.
Bye!